there's an overarching question: is which language should Robert implement next? So you're free to chip in with which is the next endeavor for Robert. Until we have some questions running, I'm going to start with an easy one. So there are many languages that don't make a distinction between the language, the runtime, and the VM. Like Python, Python is Python. There are some that make a distinction, like Java and JVM, but still they are pretty tight. But Erlang, OTP, and the Beam, they are different because they are like this. Like we have the Beam, and it's its own thing, and it's pretty big in a sense, the capabilities. And then we have Erlang, the language, and then we have OTP, which is not the standard library. So what I would like to ask Robert is how did you end up splitting it in that way? Like which were the constraints, and like how do you decide which things goes where? Like for example, why actors go in the Beam and not as a library or an OTP or something like that?
Okay, so the first thing is that the Beam and Erlang, the language, are very closely connected. So everything you'll find in the Erlang language is implemented in the Beam. The Beam runs Erlang, that's it, right? So it's very closely connected there. And what we're doing, when we're trying to develop Erlang, what we want to try and do was, well, make it relatively general in that sense, but make sure that the primitives in the language are quite simple, basically quite simple, which would allow you to build whatever type of construct you would want on top of it. So if you look at the basic Erlang language, let's say the concurrency primitives, the error handling primitives, they are very simple, literally, really. And this was a goal to try and keep it simple. With the other goal that on top of that you could build whatever type of complexity you want. Okay, so that's what you find. That's what you find in OTP. So OTP uses the ideas and the primitives in Erlang to put a layer on top with things, with nice stuff, right? Like the behaviors and the supervisors and things like this for it. They're built into OTP. That's all written on top in Erlang. And we felt that we didn't want to put that in Erlang because that could limit the language to quite a lot if you did that. Also make the implementation much more complex and more difficult. That's why.
So do you agree that Erlang is the simplest of the components in the stack, like the Beam and OTP? Like, which is kind of like weird in language land. Like there's this expectation right now that languages should all the time like be adding new features. And if you see like the recent history of Erlang, in the last, like, I don't know, 5 releases, it got maps, which was a nice addition. But most of the features went to the other parts, like to either to OTP or to the Beam. Was that an active decision? Like, it sounds like Erlang is like a DSL for the Beam in a sense, or for OTP.
Partially, because we put a lot of effort in trying to make the language simple, the basic language simple, right? And I have a fantastic Dijkstra quote I love about that one. He says, "Simplicity is a great virtue, but it requires hard work to achieve it and education to appreciate it. And to make matters worse, complexity sells better." Right? And it did take a bit of thinking to get the right primitives in the language so it could build things on top of it. That was a goal for it. And of course, we had a lot of ideas how you'd use these primitives, how you use the constructs to make your systems, your fault tolerant systems, things like this. And they went into OTP. So OTP packages those ideas we had in a nice way and gives a layer which you typically use for writing stuff. Okay.
Yeah, and I was going to say a thing. I will go to the next one. I had a question ready for you. Yeah. And Francesca mentioned that I was the second to fail trying to implement object orientation on the Beam. The first one was Ria, and I don't want to bring you to the group, but you actually managed to have a pretty functional implementation of object orientation with flavors in LFE. Would you talk more about that, and like which trade-offs did you have to like?
Do? Yeah. So when I implemented LFE, I was very fascinated with the Lisp machines and the language they were using, and they had a package called flavors on top. they didn't really call it object orientation. It was sort of before the object orientation system, but it had a very nice set of features I very much liked. And you could use it to build object orientations, the typical cases with classes and class hierarchies, etc. But it's a bit more general than that. And they had a concept, well, they call them objects, things, instances, and you need to implement those. Then they were globally accessible, but they had their own state. And so you could make, yes, you can make it as a normal data structure, but then they wouldn't be globally accessible. So the way I chose to do that is what a lot of other people have done with implementing objects, is make them processes, just having them as separate processes. And then you can communicate by sending, you literally send messages to them to communicate, not just say it, sending messages, right? And then that was what I used to build the object orientation on top of it, to build the instances for it. And then, of course, the classes and the code, of course, they're just modules in that sense. That works fine. There are some, it's more slower than what you normally expect objects to be. And you can get in some, excuse me, you can get in some really nice catches for doing things like trying to send a message to yourself. That then sit and wait for the reply. And if you don't get that wrong, of course, you'll block, especially if you have a instance A sends a message request to instance B, which sends to instance C, which then sends back to instance A, and they're all just sitting there waiting for replies. That's a beauty, right? It's very difficult to get around that problem for that's a problem for the object. It just doesn't really fit.
Yeah. Yeah, but that's something we could ask Alan Kay, because Alan Kay said that he doesn't like that he called it object orientation, because for him the most important part was messages, and we should ask him like the problem on implementing object orientation on the Beam is that if you implement objects as processes, which fits really well with like how the world works, the problem is that if an object or process sends a message to itself, it's waiting for the reply at the same time that the message comes back to you. So how it will be interesting to ask Alan how these does.
I don't know if he was thinking synchronous messages or asynchronous messages. If we keep it asynchronous, then there's no problem. But then it's typically not what other object-oriented systems do. You send a request and sit and wait for a reply. If you want to do it asynchronous, you wouldn't send the request. You send a message to them and say, yeah, send me the message back with this value. Then everything's asynchronous. That works, but that's different from what most object-oriented languages do, how they work.
Yeah, I remember the question I forgot before, and it's something that was a big surprise for me when I was just new to the community and I was following the mailing list back in the days. And there was a thread. Somebody was proposing a new feature for Erlang. I don't remember what it was, and somebody said, okay, if we are going to implement a new feature, then we have to remove another one. And it was not only like something somebody would say, but it happened. Like Erlang removed support for parameterized modules and for an experiment for namespaces. So it's not like something you say, it's something that actually happened. But it was for me a big surprise, because it goes, not only it's not like what usually people expect and what happens, that languages are always evolving and adding new features, but they are going against, like they are removing features. And if you want to comment something about that, but in general, like, do you have a language design philosophy? Did Erlang had one? Do you have more than one?
I think it was Joe Armstrong who said that. And I think that's part of the philosophy had. We want to try and keep it simple, right? Keep it general, get the primitives right. So you can, on top of those, you can build whatever you want. Because every time you add a feature, you're going to make the thing more complex, and then you'll start getting interactions between things. And typically you might get interactions things you never expected to get that, but I put this feature in here, but that will act with another feature here and interact with that and make things strange, right? So therefore, we want to keep the language simple, and they've kept it simple as well to do that for it. And that's what Joe was meaning, that if you put something new in, you should remove something out of it to do that. That's one reason why it took so long to get maps. Another was, of course, just working out what a map should look like and how it should work, and that was another problem. But they've been very conservative about doing things.
Yeah, and also something, continuing with the topic of taking away things or things that are not there. Something I really like about Erlang encoding on the Beam is the things that are not there. Like, I love that we don't have async await, we don't have promises, we don't have features, futures. We don't have so many things that are added to other languages to deal with the fact that they don't have a good concurrency primitive. And you just, I love to make an HTTP request in Erlang and block and wait, knowing that you're just blocking the process that's waiting for the request, and that's the only thing you care there about the result. Everybody else can do whatever they want. You can just block, no async await, no, like there's a blog post somewhere like that. Languages that are async await split into two languages, like the code that is async await and the code that's synchronous, and not having that split is great, and not having promises and callbacks and whatever. So loving the language by the things that they don't have, it's interesting.
Well, I mean, why add futures and promises? We can do it. We can implement them, right? But there's no need to put them in the language. We can make a library on top that does that.
Yeah.
So why do it? I mean, same thing with a supervisor. There's no need for supervisors in the language because we have the supervisor, an implementation of a supervisor in OTP, and that just uses the basic ideas, the primitives we put in. And one of the things we want to do with these primitives was what a supervisor does. Manages process, keeps track of them, restarts them, everything like this. That's just one of the features we wanted. So there's no need to put in the language because we have the library. And one thing I think is fun is you can write your own little supervisor, not as complex as the OTP one, but you can write your own supervisor in Erlang in less than 1 page of code, which does that, starts processes, manages them if they die, restarts them, and things like this for it, because that's what the mechanism was designed to do, well, amongst other things. But yeah, that's why, right?
So any feature you would like to remove, any feature you would like to add, or any feature you would like to replace? In the language or at any level, I mean.
Yeah, I'm not going to get into the syntax argument, okay? We'll leave
Change
that
the
out. Syntax. One thing that happened, I don't know if it's called a feature, but you'll find is that seeing the language evolved, as our ideas evolved, as our initial users came with feedback and things like this, and libraries evolved, is that it's been very difficult to change things. And maybe we have links and monitors. Maybe we could get, if we go back and do away, we merge these together to get the same functionality, but not so separate and things like this for it. In many ways, it's a trivial thing for it. In the syntax, maybe we wanted scoping, variable scoping or stuff like this. I don't know. We don't have that now. Well, we took Prolog's variable scoping, which doesn't have it. So that's why.
There's different scoping at core Erlang level.
Yeah. Core Erlang internally has variable scopes, but they do that by hacking the variable names and stuff like this. They do that. But that might have been something to do, and we could have done, but at that time we're just too late. And that's something we found the same with the libraries as well too. I mean, we get complaints about the libraries, and a lot of them are perfectly correct. Right? The naming is inconsistent, the argument ordering is inconsistent, stuff like this. And they're correct, and it's right. It is like that. But whenever we got complaints about this, and we suggest, okay, we'll change libraries, and we'll fix that. Then they'd come back and say, no, you can't do that because they'll crash our code. We'll have to rewrite everything. So don't change it. We don't like it, but don't change it, man.
Change, but don't change.
Yeah. So yeah. And that was just a feature of the fact that everything evolved as our ideas were evolving and new things came in. And you can see that if you look in some of the primitives of the language, when they succeed, they return true. They return the atom true. Now, later ones return the atom okay, which is slightly more logical for it. But the true comes from the old Prolog days, right? That's and again, we had that in there. You can't change it because someone will fail on that, and they'll hate you for it.
So, of course, you developed Erlang, which has the benefit of being created like from scratch in a sense. But you also developed other languages on the Beam, and they can be like in two groups. The ones where you take ideas from other languages that you like and you adapt them to play to the strengths of the Beam. And other ones where you go like hard mode, challenge mode, which is like you take a language that exists and you try to port it 100% compatible, and they are like different trade-offs. Do you have like any comment or experience or fun or times when it didn't work? Like you say, no, it's too hard. I'm not doing this.
Well, I think if you're implementing a language, any language, in this case, on top of the beam, you have to decide what your language is going to do, what's going to be used for, right? What's important for it. So with LFE, and this is the same for Elixir, by the way, is that one of the design decisions I made is I knew that I could not implement common Lisp or scheme without changing the handling of memory. And I said, no, I don't want to do that. I want to keep, excuse me, I want to keep the basic memory handling as it is. Right? For example, we don't have mutable objects. We use the Erlang's way of handling code and stuff like that for it. And that's what went into LFE. So it's very much in some way sort of syntactic layer on top. And this is exactly what Elixir does. That means you get all the benefits of the lower level for you. Everything's there. Everything that happens in there, every improvement in the virtual machine, you get that for free. And that was just a design decision I made with LFE. I wanted to be like that. When I was looking at LuErl, which is an implementation of Lua, I wanted to go the other way, explicitly go the way and say, yeah, I'm going to implement Lua with exactly as Lua does. And amongst other things, Lua has a shared global mutable data. Everything Erlang and the Beam doesn't have. So that means, okay, I will implement that on top of the Beam memory management. Another choice there was I wasn't going to add things like NIFs or make changes in the virtual machine. I want to be running on top of standard Erlang. And that's just a choice you make. Okay, but you decide what you want to do. And for the Lua case, I wanted my LuErl to run Lua. So you can take your Lua code and run it straight on top of it. But that was a goal decision. I was willing to have the extra, pay the price of implementing this type of memory, and this type of state, and this type of code handling on top of our language is completely different. Again, it's a design decision. The Erlang, my logic language there, that's Prolog. It's the same thing there. It's running Prolog. Right? It's got stacks, immutable, very well, backtracking and all this type of thing on top of it. Right? It's a design decision you make when you're implementing language. I mean, when you implemented Effene,
yeah,
you also made a decision. What am I going to? It's Python, but how Python is it going to be, right?
Yeah. The usual question I got was, well, if you want to implement something like Python for the Beam, why don't you implement Python on the Beam? And I didn't go the LuErl path, which is to say, yeah, I will try it. I went more the LFE or Elixir path, which is which things do I want to keep and I can keep without paying a huge trade-off, like not being able to interoperate with Erlang or having a performance penalty. And also I knew for experience in the Python world, everybody wants better concurrency or more performance, but like if you don't give them 100% compatibility with CPython, they are not going to take it. The biggest one is there's an implementation of Python that's 7 times faster than CPython, and it's almost like 99.9% compatible with CPython. But sometimes some C extensions don't work, and like nobody uses PyPy. So, and I was not going to be 7 times faster, and I was not going to be compatible with C extensions. So I said, like, let's do the LFE style, which is like take the stuff I like and play to the strengths of the Beam. And I'm not good at marketing, it seems, or it wasn't good enough. So, but yeah, I went that path. And the other one I went, when I tried to go I never implemented, but I may at some point. I went the LuErl, which is I wanted to implement a fourth on the Beam, which is like alongside mutability is the worst decision to try to port to the Beam, because like fourth is a stack language. So if you have a stack, it's nice. And the Beam is one of the only mainstream VMs that it's not stack based, like CPython and others is register based. So if I wanted to implement a stack language, I will have to simulate the stack. Basically what you do in LuErl, which is you pass around the context. In your case, it's the immutable state. In my case, it was a stack. I will have to pass the stack all over the place, which meant that it wouldn't interpret without glue with other languages and anything. It's a nice challenge. I may take it again, but at that point, I say I don't want to. Like I don't want to force this so much.
But I think that's just when you're implementing a language, even a small DSL, you have to make a choice of what you want, right? What's important for you in this language, and what am I willing to pay for, and what am I willing to sacrifice for it? You make that design decision when you do it. That could be, I mean, it could be something. It could be a 1 day or a one week hack where you're putting it together a language just to test an idea, or saying, is in this large system, can I make a little DSL do this here? Would it be worth the effort or not? Right? You can just make it or test it, but you're still making a choice what you're going to do, what's important for you. You need to do that. Otherwise, the language will just wander off everywhere.
Yeah,
it just won't work in the long run. It'll just be too complex. Too many different things are going on in it.
Francesco, you can correct me. I'm checking the questions. People are really shy, so I'm going to keep with my questions. I have many, but I'm not seeing them. And the global question is, which language should Robert implement next? But you can make other ones. And like, we are running out of time, so a closing one is to pick the one you want. Which things you see right now in the ecosystem that you like, and which things you would like to see more of. And if you have any advice for people that would like to start implementing languages in general or on the Beam in particular.
I think the advice for doing that is decide what your language is going to do. I mean, yes, you might choose, I'm going to implement language X, the existing language X, right? And you're going to say, do I want all of X or part of X, and do that. And otherwise, work out what the language is going to do, what's important for you, why you're doing it. It might be just for a fun hack, right? That's perfectly fine. I like implementing language. I can completely understand that. It doesn't have to be something that goes all the way, but just work out what you're after and what's important. Choose that for it. And what system you're going to implement it on, that again depends how you want to use it. So the reason for implementing LuErl on top of Erlang, because I want to be able to run it in Erlang, like every Erlang thing as well too. That was why. You just have to make that decision for what you want to do for it. And the language, the next language, yes, I'd like to implement another language, but if I'm going to implement a real language, an existing language, it's a language that would actually be useful to have on the bed. That people would use. Okay. So I can do it for fun, but if I want to go all the way, what will people use, right?
And many have suggested JavaScript.
I was actually looking at JavaScript before LuErl, but I had a book called JavaScript: The Good Parts. I borrowed it from Joe Armstrong, and there's a few appendix at the end saying the bad parts, right? And they started getting me, so I thought, no, I'm not going to do JavaScript. That was just too bad. But again, would anyone seriously be interested in having JavaScript on the Beam? I don't know. I'm asking the question here. What other language would be interesting to be actually seriously used, to put the effort into making it going all that way, not just testing an idea, right?
I think it's addresses, I think, a lot of the issues of the V8 engine running on the Beam. And I think a lot of the flaws which you see in Node today.
Yeah, we are running out of time, I think.
Yeah, we've got the flag now, so yes, we'll do that. Yes. I see that in the show. I see the thing.
We have a 9-minute buffer.
Sorry? I'll be on Toucan later. So if anyone has questions there,
we will be on Toucan, so we can continue there.
Yeah, we can do that.
Cool.